really cold today. Boy, oh boy. It is definitely chilly here in Niagara Falls, Ontario. I should probably have my jacket done up today, but it's mid-January 2024, and today is part 2 of our 5-part series on the DR650's electrical system. Today, we're gonna take a look at the charging system of the bike. So why don't you sit back, grab yourself something warm to drink, and enjoy Dino's Tinker Shed. I gotta put the heat on here for a few minutes to get the temperature up, but I'll see you in a minute. Ugh. Whew, okay, I'm just going to turn that heater off for a few seconds here while we do some talking. It is about -15 out here in the shed today, so I'm intermixing some B-roll shots with this kind of talking. But what are we going to talk about today? Well, today is part 2 again of our electrical system on the DR650. Today we're going to take a look at how your battery is charged using a couple components on the motorcycle and how to test those components, specifically how to test your stator and how to test your regulator rectifier. We're also going to do a couple tests on your battery and talk a little bit about the battery in general to make sure it's in good condition and it's not seeing losses in terms of voltage where it isn't supposed to see losses. That's what's called a parasitic draw. To do all of this, I'm basically going to follow along in the climber's manual here. I would recommend buying either a climber's manual or seeing if you can source out the factory service manual when you're working on electrical. We talked about that in part 1. But what I'm going to do today is pretty much read verbatim what's in the manual here and perform those tests as we go along. So I hope this will be helpful in case you're trying to trace out some electrical problems. Now, I am again going to state, I am in no way a mechanic here, and electrical work on automotive and my motorcycle and snowmobiles is probably my weakest skill in terms of how I enjoy the hobby. I don't really enjoy electrical as much as I do replacing other sort of mechanical components. But this is part of what I want to learn a little more about, and I'm taking you along for the trip. So why don't we get started talking about the electrical charging system. So you're having problems with the charging system on your DR650. Where do you begin? Well, I'm going to start with what's known as a regulated voltage test. What we're doing is we want to see what kind of output the charging system is producing currently. To do this, we need a multimeter set to DC 20 volts. We need to make sure that our battery is fully charged between 13 and 13.2 volts. And we need to start the motorcycle and let it warm up until it reaches operating temperature. Once operating temperature is reached, we use an induction tachometer around the spark plug to allow us to rev the motorcycle to 5,000 RPM. That's where this test is performed. Then, using your digital multimeter, you're going to see what kind of voltage output you're getting from the charging system by holding the 2 probes on the negative and positive side of the battery. According to the manual, we should be seeing between 13 and 16 volts DC at the battery at 5,000 RPM. If you're seeing less than that or more than that, you have a problem with the charging system. So how do we start to determine what this is? The first thing that I want to do is really simple stuff. Let's look at the simplest things. All models of the DR650 are equipped with numerous electrical components
connectors, and wires. Corrosion-causing moisture can enter these electrical connectors and cause poor electrical connections, leading to component failure. Troubleshooting an electrical circuit with one or more corroded electrical connectors can be both time-consuming and frustrating. When reconnecting electrical components, pack them in a dielectric grease compound. Now, dielectric grease is specifically formulated for sealing and waterproofing electrical connections without interfering with current flow. Use only dielectric grease compound or an equivalent for this specific purpose. Do not use a substitute that may interfere with current flow, such as just regular grease or silicone sealant. These really aren't the right product to use.
And this includes checking all of your grounds, especially your main ground. If you don't have a good ground, your battery and your charging system just won't function properly. Now on the DR650, the main battery ground is tucked inside here and it's attached to the engine case itself. It's a little hard to see on camera, but it's right up in here. You should take this apart, clean the back of the bolt surface, so the back of the head, not the threads, clean the connector itself, and clean the contact patch on the engine with a little bit of light emery cloth, just to make sure that everything's good. Bolt it all back together and snug it up, and then it's never a bad idea to coat that with just a little bit of dielectric grease to protect it from corrosion. I do want to address something about dielectric grease, and that is the debate online about how to really properly use this stuff. If you get online and start reading about how to use dielectric grease, many people sort of have an opinion that you should use it and smear it around the sealing surfaces of the plastic connector, and that will seal the connector from any moisture penetrating into where the metal contacts are. The manual for the DR650 from Climber, however, is very specific. It says to pack the connectors with the dielectric grease and even pack the backside of the connector where the wires enter into the connection areas. I believe the debate is that if you pack it full of dielectric grease, there's the potential that that dielectric grease may impede electron flow across the metal connectors within the plastic housings. To test this, this is a giant gob of dielectric grease here. I have my multimeter set to the continuity setting, so if I test the leads or touch the leads together, you can hear that continuity, no problem. There is no continuity between the cardboard, obviously, and if I submerge the two leads within the dielectric grease does not allow any form of connection between these two probes. The thought is when you bury your connector inside a gob of this, it will impede the ability for the two metal connectors to conduct electricity well, and the continuity will be poor. So I'm just going to submerge these. You can see that works quite well. And in fact, we have like 0.001 ohms of resistance on there. So it works fine. It's going to keep the moisture out of your connectors and seal everything up. I don't know what's the right or wrong answer. I just know that the manual says to pack those connectors with dielectric grease, and that is what I'm going to do as I move forward in this series. So if you have an opinion on that, by all means, leave it down in the comment sections below, especially if you have more knowledge about this than I do. Again, electrical, Dino don't always go good together. Okay, what's next?
In some service procedures, it's going to require you to disconnect the battery cable from the negative battery terminal. To do this, you turn off the ignition switch, remove the seat, and then you're going to remove the battery hold-down retainer that's held in place with two bolts. Remove the bolt from the negative battery cable that's basically threaded into the battery. Then you can move that cable out of the way and secure it so it cannot accidentally touch either the negative or positive side of the battery. And a zip tie can work good for this if you're worried about it. You can also remove the positive post and tie it back as well. And you can now slide the battery out. And if you really are looking to trace out some issues, especially on charging, you're going to want to start by cleaning the battery. So pull it out of the bike, take it over to the bench, use a solution of warm water and baking soda and an old toothbrush, and just gently scrub the entire battery down with this. And this will neutralize any kind of battery acid that might be on the outside. It cleans the battery off and it allows you to look for any cracks or damage. Now, most of these batteries are sealed right from the factory. You can't open them up and add electrolyte unless the battery's been replaced by somebody with an open cell type battery. But once you inspect the battery, if it's in good condition, you can also take a small brass brush or a little bit of emery cloth and clean up the posts themselves, and then give them a rinse as well. And just let the battery dry out for a while before you go and test it.
Now that you have your battery all cleaned, including the terminals, this is the time to do a battery no-load voltage test or a static voltage test to see where the battery is sitting. All of this test should be done in a room that's about 20 degrees Celsius or 68 degrees Fahrenheit to get proper readings of your battery. And it's a good idea to use a 2 amp trickle charger for about an hour to make sure your battery is topped up. Now, once that battery is topped up, let it sit for about an hour off of the charger to stabilize the battery. It'll actually drop in voltage a little bit over that hour, but then it should hit a stable reading. Take your multimeter here, put the clips on the right terminals, and see what your battery voltage is. Now, a good voltage is between 13 and 13.2 volts as a static battery voltage. Now, if you have less than that, say less than 12.8 volts, probably your battery is getting tired because it's discharged all the way down to there in about an hour. And you're probably going to be looking for a new battery, especially if the battery's 2 or 3 years old or in a really rough environment like the DR650. If you do have to buy a new battery for your DR650 or any motorcycle or power sport, make sure to check the charge on the battery before you install it and put it into service. Many manufacturers and retailers will tell you that the battery is ready to rock as soon as you buy it, but in reality, many of these batteries come with the charge less than 100%. If you put that into service, there is the potential that the battery will never take 100% charge. So do yourself a favor, get your trickle charger, put it on the battery for a few hours and verify that it's around 13 to 13.2 volts before you install it into the bike. If you have time, it's a great thing to do, and it may save you from a dead battery later on down the road. One of the most common issues with the charging system that a motorcycle or power sports owner has is a battery that discharges way faster than it should when the bike is sitting. So maybe you leave it for 2 or 3 days, you come back, you go to start the motorcycle, and the battery's dead. Now, this could really indicate that your battery is old, and if it's 5, 6, 7 years old, it's probably a good bet that's the problem. However, if your battery checks out and you still have that flat battery after a few days, chances are you have some kind of parasitic loss throughout the bike's wiring system. And you can trace this down doing what's called a parasitic draw test. It's a fairly easy test to do, and all you need is a multimeter and some time to trace this out. So why don't we take a look at how to do that right now?
Machines that maybe have a clock or some other type of aftermarket accessory such as an alarm or maybe heated grips, or in my case I have a dashboard with some USB stuff hooked into it, may have a continuous parasitic loss if they're not wired into the device or into the motorcycle correctly. This will show up as a current draw at the battery. However, any current draw present when all electrical devices are shut off indicates a problem. So you really don't want to have your heated grips drawing on the battery in any way when the motorcycle is turned off, or you'll wake up in the morning and you won't be able to start it. A short in a wire or a component can allow the battery to discharge to ground, and dirt or moisture can also create a pathway to ground. To isolate this problem, an amp meter is connected to the battery and various circuitry components disconnected while observing the current reading. And here's how we do it. First, we turn the ignition switch off. We disconnect the negative battery cable, and in some cases we need to remove the fuel tank if we need to get to different connectors. You also want to make sure that your battery is fully charged, so plan this procedure, use that 2 amp trickle charger, and make sure your battery's in good shape before you start. We also want to make sure that we set up our amp meter correctly, or our multimeter into its amp reading state. So I'm going to take my common black lead and I'm going to place it in the common port on the multimeter. And I'm going to take the red lead and hook it into the 10 amp fused port on my multimeter to start this test. Before connecting the amp meter in the next step, you want to set the amperage range to the highest setting. Otherwise, the meter may be damaged if there's any excessive amount of current flow. Mine is fused at 10 amps and also is auto ranging, so I shouldn't have to worry about this. But if you have a manual style multimeter, you want to make sure that this is the case. Take your multimeter and connect it to the negative battery cable and the other lead to the negative battery terminal, basically placing your multimeter in series on the negative side of the battery. At this point, the battery should indicate no current draw at all because your ignition system is turned off. However, if a current draw is indicated, then you can start by removing fuses from the headlight and taillight circuit. If you remove one of those fuses and the current draw lessens, then you will have a problem within that lighting circuit. If, however, you pull each fused circuit out and you continue to have that current draw, then the current draw is on one of the unfused circuits within the motorcycle. To test these, I would start as far away from the battery as I can using the wiring diagram, and then disconnect each connector one at a time, observing the multimeter to see if that current draw disappears. If you do unplug a connector and the multimeter zeroes out, then that means from that connector out to the load is where your parasitic draw is. If you don't have any parasitic draw, you just keep working your way back until you get as close to the battery as possible, and then start on the next circuit furthest away from the battery. This is super time consuming, but it is oftentimes the only way you're going to find a parasitic draw.
Well, it doesn't look like we have any parasitic loss on this DR650. So maybe we have a problem with the charging system overall. Maybe as we're riding it, it's not topping the battery up the way it's supposed to. So let's talk a little bit about what's involved with your charging system.
Now that our battery is nice and clean, it's charged and ready to go, let's take a look at the system that actually charges it. The charging system consists of the battery, the alternator, and a voltage regulator rectifier. And a 30 amp main fuse protects the circuit itself, even though on this diagram it says 20 amps. Alternating current is generated by the alternator and is rectified to direct current. The voltage regulator maintains consistent voltage to the battery and additional electrical loads such as lights or ignition or maybe heated grips, despite variations in engine speeds and loads. Let's take a look now at the alternator. The alternator consists of the flywheel rotor and the stator coil assembly, and the whole assembly is located underneath the cover on the left side of the bike. The stator coil consists of separate coils that generate voltage for the charging system and lighting system. The rotor itself is a permanently magnetized item, and it can't really be tested except by replacing it with a known to be good rotor. The rotor can lose magnetism from old age or a sharp hit, such as dropping it onto a concrete floor, so handle this thing carefully when you do take it off and place it down on something soft like a workbench with a rag on top. The stator has a wire connected to it that exits from the back of the engine case on the left-hand side of the motorcycle, and that wire goes all the way up in behind the frame rails. I have found that by removing the secondary air filter, you can gain access to see where these wires go, and you're looking for these yellow wires that are coming up here.
Here's the connector for the stator. You can see all three yellow wires coming in. There's a little black tab right here, and I'm going to push in and down on that while holding the plug. So I'll push in and down, and this one came apart relatively easy. They don't all do that. You can see that we've got three connectors here, three spade connectors, one for each of the yellow wires. What we're going to do is we're going to use our multimeter set to ohms, and the lowest setting on ohms if you don't have an auto ranging like I do. And we're going to take our probes, we're going to insert one probe here and one probe here and see what our ohm readings are. For the DR650, those should be between 0.5 and 0.9 ohms. Then we'll probe between this terminal and that terminal. It should have the same 0.5 to 0.9, and ultimately this terminal to this terminal. So basically we're checking between all of them to see what we have. Once that's done, we are going to set our multimeter to continuity now and probe between each one of these spade connectors and a known good ground, such as this part of the bike here. This will tell us if there's any voltage leakage from the windings on the stator coils themselves. If you have way too high ohms of resistance, or you have continuity between these plugs and a ground source, the stator is probably bad and you need to change it. As you can see, my stator's ohm resistance is a little bit low. It's around 4.6 to 4.9 instead of 0.5 to 0.9. I'm not really too worried about it because the bike's been sitting out here in the freezing cold for days. So even though the shop is warm, it's probably a little bit colder than it should be to do this test. So I'm pretty confident that I'm very well. Like, I have no charging issues with my bike at all. The next thing we need to test is voltage output on the stator itself. And to do this, we actually need to start the bike. So the test that we're going to perform is called a no-load voltage test. And what we're going to actually look for is the output voltage from the stator coils in alternating current, AC voltage. That AC voltage is going to travel down to the regulator rectifier and be turned into 12 volt that the bike uses for general everyday consumption. What we're going to do is, using our multimeter set to AC voltage, we will probe 2 of the 3 wires within the connector at any given time. So the same type of process as we use to check ohms. The difference here is the multimeter is going to be reading AC voltage coming out between those 2 coil wires, and it should be around 75 volts AC. We'll do the same type of process where we probe all 3 wires. So we'll do these 2, then these 2, then these 2 in that triangle shape, and we should see 75 volts coming out of all 3 combinations of wire probing. Now you can do this just with a set of regular probes. What I did is I made this pair of spade pigtails that just plug into the harness and has some bare wire here that I'm going to use my multimeter leads with alligator clips to make it a little easier. The other thing you need to realize is the bike should be running at 5,000 RPM. And this is where a remote tach on the DR650 will yield the best results. You slowly raise the RPM up to 5,000 RPM, read the reading on each one of the coils. If you don't have one of those tachs, you can still rev the bike up and continue to rev it until you see that 75 volts, or you may never hit it. You're going to know if you're over revving the bike because you ride the bike on a routine basis. All right, we have 75 volts on each leg of our alternator there, meaning that the stator and rotor are in good condition. And you did see how high I had to rev the bike to get to 5,000 RPM. It really is a good idea to buy one of these remote tachs, this induction tach that you can just wrap around your wire on your spark plug, and it'll tell you exactly where you are when you're doing testing like this. Now, if you were unable to hit 75 volts or close to 75 volts, more than likely you have a problem with your stator or your rotor, and you're going to need to change those out. I'm not going to show you how to do that in this video. I'm just showing you how this charging system works and how to determine what part is failing. All right, what's next? With our stator checking out, there's really only one more piece left before we get to the battery, and that is this piece here, which is our regulator rectifier. The purpose of a regulator rectifier is just like what it sounds like. It rectifies the AC voltage to DC voltage, and it regulates it between 13 and 16 volts so you don't overcharge or undercharge your battery. These are easy to get out of the bike. They're only held in place with 2 screws right here and a wiring connector underneath. And then we can put it up on the bench and test it. Now, testing this requires the use of the manual again because you're going to probe across all of the contacts looking for ohm resistance. But they can be a little bit tricky. They have diodes in them and all kinds of other things that sometimes make them a little bit fussy to test. But I'm going to put this one up on the bench and we'll have a look at it.
I have the regulator rectifier up on the bench, and I'm just holding it vertically here with a simple spring clamp so I can test this easier. We're going to use figure 10 from the manual, which gives us a chart of resistance between the different pins here on the regulator rectifier. And it is important to note that when testing for ohms on a regulator rectifier, they have diodes in there, meaning the polarity where you place your black and your red lead is very important to getting any reading at all out of these. These are listed as R, BW, Y1, Y2, and Y3 within the connectors. And each one of these has different values, but they range between 1 and 20 ohms. So when you turn on your multimeter, like I am here, and you select the ohm scale, if it's not auto-ranging like mine, you need to be able to read between 1 and 20 ohms. So you're going to need to select the correct range within your multimeter. To start, I'm going to probe between the BW connector up here, and I need to use my red probe to touch that. Next, I'll go down all of the Y connectors here, and these should give a reading between 1 and 10. So let's see if we can do that now. 2.75, 2.8, 2.82, those are all within range. Now, between the BW and the R connector, we should see between 1 and 20 ohms of resistance. So let's just check that. And we're getting 4.8. So that is well within spec. Next, I'm going to switch and use my black probe on the R connector up top here, and I'm going to go all the way around again. So I'm going to check 2.7, that's within spec. 2.7, that's within the 1.10 again, and that is within the 1.10 as well. If I probe up here, I get 4.8, which is exactly in spec.
Now, if you have connectors in your regulator rectifier that don't match the ohm readings as per the manual, more than likely your regulator rectifier is defective, and that's your problem. You can always take this down to the dealer and have it tested if you're not 100% sure, but if the ohm range is completely out of whack, you're getting way too much resistance, or you're getting an open circuit no matter how you test this, more than likely that's your problem. If you do have it that it looks really good, the next thing to do is just reinstall it into the motorcycle and perform another regulated voltage test to see if the charges come back. Sometimes just jostling all of the connectors, cleaning all your grounds, and putting everything back together can resolve your problem. It may have vibrated loose or something's been corroded. So remember, you want between 13 and 16 volts at 5,000 RPM. If you do need to replace this thing, it's somewhat of a common issue. They do burn out after time. Buy yourself a good quality stator or regulator rectifier, either a factory one or from a very reputable dealer such as RM Stator in Quebec, Canada. I've bought lots of different stators and regulator rectifiers from them over the years for different projects, and I've always had a good success with them. They don't pay me to say this. I'm just letting you know they're a good product to have. Well, I hope you enjoyed today's episode on the charging system of the DR650. This was a very challenging episode for me to make. That's why it's taken a few weeks for me to get it up and out. And it'll probably be the same for the next 3 parts of this series, the next of which is the starting system. If you do like this type of content, please, by all means, like and subscribe to the channel. It really does help it out. And if you can, leave a comment and let me know what you think. And once again, I am not a mechanic, so if I'm missing something or giving the wrong information, please chime in down in the comments and let everybody know, especially me. So until then, you have yourself a great day, enjoy the weather, whatever it is where you are, and remember, tinker easy. Bye for now.